and we already used it. This is not a good stylus. This one's much better. It's styling. All right, today we're going to talk about triangle inequalities. What we're talking about inequalities is basically going to be able to say like one angle is bigger than another angle. So before we read this, let me just talk about what I'm saying. Let's say I'm going to make a very obviously different triangle. So we'll do this. We'll do this. We'll make it very obvious. And we'll do this. And we'll say this is 20 and this is 5. Is it really easy to picture that this angle is smaller than this angle based upon those numbers and the shape of it? Yeah, that's what we're doing today. We're doing, hey, if this line is really, really long and this line is shorter, this angle must be smaller than this one because you need a big angle to open up for a bigger line. A smaller line needs a smaller angle. That's the backbone of what we're doing today. So triangle inequalities allows us to order sides or angles of triangles by lengths. It does not give us exact lengths, just relative lengths in order. Like I said, we knew one of these angles is bigger than the other. I don't know the actual value of this without calculating a whole bunch of stuff, but I can say it's bigger than the other one. And the last thing it can do, it can help us to determine whether triangles can even be formed. All right, we have two big theorems in this. Our first one, which is Theorem 6.2 out of the book. I am not going to give you a theorem sheet for this one because we aren't proving these. All right, they're just things you have to know. So our first one says, if one side of a triangle is longer than another side of a triangle, then the angle opposite the longer side is longer than the angle opposite the shorter side. Whew. Did you get all that? No. I don't know what you said. Let's look to the right. We have a picture of exactly what we're talking about. So we have a triangle, and we have one length is longer than the other length. That's what it's saying. So that's what the theorem starts off with saying. Hey, if I have one length longer than the other length, so we currently have length AB is bigger than length BC. So, what we can say based upon this theorem is since AB is longer than BC, the angle opposite 8, must be bigger than the angle opposite that 5 or that side BC. In other words, since AB is bigger than BC, we can say definitely, without a doubt, the measure of angle C, because C is across from AB, is bigger than measure of angle A. Ooh. Because A is across from BC. This is the same thing as what we did here. This is just a more extreme version. It's a very, very obvious one is bigger than the other. So for this first theorem, all we're saying is if I have a triangle and I know the lengths of all the sides, I can order the angles from biggest to smallest. I don't know the values, but I can order them from biggest to smallest. The next theorem is just the converse of this. The next one, if you want to read all that, by all means, it is saying, let's say I know two angles. I know this one's 50 degrees and this one's 30 degrees. So based upon that drawing, I know that the measure of angle A is bigger than the measure of angle C. This theorem, which says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. That's saying if I know that measure of angle A is bigger than measure of angle C, so I can go ahead and say that the side opposite that 50 degrees, or side BC, is going to be bigger than side AB. This is just the converse. Yes?
A question about like formatting. So if I'm like writing something like that on the test, like measure of angle C is greater than measure of angle A, so could I just say measure of angle C and then actually write out is greater than measure of angle A?
Use the greater than sign.
Well, because of the kind of like the angles, kind of like they kind of confused me when I wrote them down.
Okay, just try to use the greater than sign. It's mathematically correct, and you're going to be using greater than, less than signs all over the place, so try to use it. I wouldn't take any points off on the test, but it's a little nuance in math books and everything alike. Try to use it. If it's just horrible, then you can put is greater than, but you have to know that symbol. All right, because that's how it's going to be written on the test. That's how it's written on all the homework. That's what I'm kind of asking for, but if you put is greater than, I'm not going to take points off on the test. Okay? Questions on either one of these two things? Do they make sense in kind of a holistic sense? Like you can just picture it, it's got to be true. It's kind of tangible. It's tangible that if a side's longer, the angle to make that side must be bigger than one to make a smaller. I feel like these are nice, tangible. Both these lessons are kind of like things you can picture in your head. All right, let's continue on. So examples, we're supposed to list the sides or angles in order from shortest to longest. So in this one, I'm given 3 sides. So we're just looking at, well, DF is the shortest side, FE is the middle side, and DE is the longest side. Since DE is the longest side, the angle across from it must be the biggest angle. So we're going to say measure of angle F must be bigger than, then we go to the middle size one, which is 12. And we look at the angle that forms 12, and that is angle D. So measure of angle F is bigger than measure of angle D, which must be bigger than the last angle, which is E, which is across from the shortest side. So measure of angle E. Take a second and try the next 2. If you haven't already, try the next 2. The next one's going to be side lengths instead of angles, because I'm given angles, so I'm actually determining which sides are the longest to shortest. Do you disagree? I'm not too sure about this statement that x is bigger than x plus 2. How is x bigger than x plus 2?
Well, I was just going from the angles, the size of the angle.
Oh, these aren't the size of the angles. This is angle 1, 2, and 3.
Oh, okay.
Because if this is 1 degree, 2 degrees, 3 degrees, that means that would be a 6-degree triangle.
It's
Which,
just not.
oh yeah, but a triangle has to be 90 degrees no matter the proportion. Okay, this one. We know that measure angle A is the biggest angle. So the side opposite must be the biggest side. So we're going to do, maybe I should do a little line here. So I'm going to say that BC is bigger than, then I find that middle sized angle, and that's angle B. The side opposite angle B is AC. And finally, I look at the smallest 137, and that is AB or BA. Let's use BA because that's where we're at. Questions? Yes?
I did something different, but I did angle A is greater than angle B is greater than angle C.
Right, but we have to use that to do the one that we don't know. So it says list the sides or angles in order from shortest to longest. So I'm going to do the sides because those aren't actually labeled. Like here, the sides were labeled. Yes, I understand that you know 21 is bigger than 12, 11. I want to know how we're going to use that with that theorem. So I went from sides to angles. This one, I was listed the angles, so I'm going to do the sides. Yes?
Is that right?
You sure?
Yeah.
All right. Positive.
No, like, I just like wrote it was in the example, but then I realized that you're putting the greater than sign, so that that cleared it up.
Oh, okay. All right, the last one. We weren't given any real values. All I'm given is x, x plus 2, and x plus 4 to figure out these angles. Well, if I have x, say x is 2, 2 plus 2 must be bigger than 2, and 2 plus 4 must be the biggest one. So x plus 4 must be our longest side. So that means angle 3 is our biggest angle. So measure of angle 3 must be bigger than measure of angle 1, since x plus 2 is the next biggest. And that's got to be bigger than measure of angle 2, because x in this case has to be our smallest. No matter what value x is, this is our smallest side. Especially because x has to, we don't think about negatives or positives, because this has to be a positive length, so x must be positive. Questions on any one of those three? That's a bulk of the homework right there, so hopefully you do understand it. The next thing we're going to talk about is a triangle inequality theorem. That says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. And the whole basis of this is based upon this drawing. So if we look at 4 and 2, 4 plus 2 equals 6. 6 is bigger than 5. So that means that if I was to swing these two sides, they'd stop at this point. And that's only because it's 4 and 2, it's bigger than 5. If they're less than 5, so say I make both of these 2, and you just let them flop, they can't even hit each other. They couldn't actually make a triangle. They're just too short. If they equal 5, they'll just create a line, and they won't actually create a triangle. So these two sides must be bigger when added than that third side in order to actually make a triangle. So these are some examples. So AB plus BC has to be greater than AC. AC plus BC must be greater than AB, and AB plus AC is greater than BC. You have to check all three scenarios. So that is basically, is 4 plus 2 bigger than 5? Is 5 plus 4 bigger than 2? Is 2 plus 5 bigger than 4? You have to check all three to make sure a triangle is even possible. So our first example says, is it possible to have a triangle with side lengths 5, 6, and 12? Yes. No, it's not. Correct. And let's go through the checks really quick. So your checks, and it's going to fail immediately, but you should still do all three checks so you know what you're doing on any other triangle. I'm going to say, is 5 plus 6 greater than 12? Don't say anything yet. You're also going to say, so we have to check all three of the things, so I'm going to also say, is 5 plus 12 bigger than 6? And finally I have to do 6 plus 12 is bigger than 5. To make sure you did all three checks, just make sure you have all three sizes on your right hand side. So I have 12 here, and I use the other two sides. I have 6 here, I use the other two sides. And finally I have a 5 here, and I did the other two sides. Make sure you check each one, and then you ask yourself, is it true or is it false? 5 plus 6 greater than 12, is that true or false? Yeah, false. Thank you, Sabrina. So this is false. This one's true. This one's true, but all you care about is one false. And as soon as you get one false, you can put no triangle. You don't have to write this down. In fact, don't write it down. What we basically have here is a side length of 12. Don't write this down because you don't have the room for it. I'm just showing you kind of what they're talking about. That is 12, bless you. 5 and 6. Those two lines would never touch each other because it reaches 11. So these will fall down and you can't actually make a triangle. That's all we're talking about there. Our next one is probably the most difficult question, and it's a hard question on the test as well. So make sure you pay attention closely and you understand what I'm doing. This says a triangle has a side length of 12, and it has another length of 8. It says find the possible values of x if x is the length of that third side. So I'm actually coming up with the whole range of possible values x can be. So what I'm going to do is I'm going to do some checks up here. I'm going to come up with an answer, and I'm going to show you a shortcut to actually do these problems. So we already know that two sides have to be bigger than the third side. So what I'm going to do is I'm basically going to come up with the different scenarios. So I'm going to say, well, 12 plus 8 must be bigger than that third side, x. I also know 12 plus x needs to be bigger than 8. And I also know that 8 plus x must be bigger than 12. So just like we did here, I'm just doing all the checks. All three sides are occupied on this side, and I added the other two sides on the other. Now I'm going to simplify these statements. So this one says that 20 has to be bigger than x. Another way to write that would be x must be less than 20. This next one, I would subtract 12 from both sides to give me that x must be bigger than, well, 8 minus 12 is going to be negative 4. And this very last statement, I'm going to do 12 minus 8, so I have x must be bigger than a positive 4. Look at these two statements. One is the one I care about, the other one is not. This says x has to be greater than negative 4, but this one says x has to be greater than 4. Yeah?
You only care about the last one.
I only care about this last one, because this is the only one that holds true for both of these. So I only really care about this one and this one, and we're going to write it into an equation. So we're going to write the equation 4 must be less than x, and x must be less than 20. Who wants an easier, yeah, sorry.
Okay, so why would you pick 4? I don't understand that.
See how this one says x has to be greater than negative 4?
Yeah.
So negative 3 works for this one, right? Does negative 3 work in this one?
Oh, no.
All three of these must be true, but this one basically trumps this one. It's like, it has to be greater than negative 4, and this one's like, no, it's got to be greater than 4 for me, all right? So we're going to pick the one that kind of has the most power. So that's that one. Who wants to know an easier way to do this than having to do all three columns and doing all this stuff? No one? Cool. Then we won't do the easier way. All right, an easier way to do this.
Did you subtract them too?
Yeah. So you can just look at this, that 4, and it doesn't matter which order you do it in. That 4 is going to be the absolute value of your two sides subtracted. So let's just say it's 8 minus 12, absolute value is going to give me that 4. Actually, did I do that? I don't even have mine up here. So that is the absolute value of our two sides being subtracted. I think I actually put, I'm trying to see what I liked better when I was actually going through this to write it. I did use the 8 minus 12. And then how do I get that 20 using those two sides? Add them. This is just 8 plus 12. So these are pretty important because these can really help you move through this pretty quickly. Good thing is on like a test, if I kind of forgot whether I subtracted, whether I used that, just check. Just check to make sure these work in these equations. All right? Or just quickly check, do the quick checks if you have time. Questions on these? No? Okay. You're going to try these next two. You can skip the C if you haven't already done it, just so you have a little bit more room. Check these, and then tell me these. So you're doing both of those. Make sure for the sake of notes, you actually do all your checks for these, okay? I want to see on your sheet that you actually check the addition on each of these, that it works, or it doesn't work.
X and stuff. Is the positive number always going to be the one you pick? Like, I don't know if you know what I mean.
So are we at number 2?
Yeah.
So is the positive number going to be that
Like,
one?
you know how you have like x is greater than 1 and x is like greater than negative 1? Would you always pick like the positive one?
For this 3 minus 4?
Well, no, because like on top, like you see on B up there, how you have 4, negative 4, or like there you would have 6 and negative 6.
Where do I have 4, negative 4? I'm sorry.
On the very top on B, it's like I'm just using that as an example too.
Up
Like
here?
X is greater than 4 and x is greater than negative 4.
Oh, do you always...
pick the positive?
You always pick the positive. Okay, I see you. I was trying to figure out 4s from here. I wasn't looking up here. All right. Yes, we always pick the positive 4, and we know that because look at this absolute value sign.
Okay.
This absolute value sign is telling you always pick the positive one. Yep. So if you're going to this method, you will always pick the positive one. Okay, I got yours. I was just looking at the wrong one. I'm like, B? Well, that's still... There's no 4. All right, yes. So you'd always pick the positive one. That's why we do the absolute value. Great question. Other questions on those? All right, then the rest is homework. Get her done. If you're missing homework from me,